Hello, my name is Taufik Hidayat bin Muhammad Rasul. Today, I with my friend from Section 2, Group H, Syed Azri Haziq bin Syed Azli and one Haikal Fitri bin Wad Ahmad Rizali would like to share to you about our lab experiment, mechanical heat pump. In this video, we will explain about the additional theory of this experiment, the objective, apparatus, the example of infographic poster that we make, the result, observation and discussion. By the end of this presentation, we will explain about the conclusion and recommendation to improve this experiment procedure in order to make it more accurate when collecting data.
My name is Syed Azri Haziq bin Syed Azli. Now I will explain about additional theory of mechanical heat pump experiment. A heat pump is a system that takes always heat from the wastewater or the surrounding to make important heat which is higher temperature than the surrounding temperature. That is to mean that heat pump absorb heats from its surrounding to maximize its interior heat content. The heat pump has more heat than the heat from the source. The main point in all types of heat pump is that the heat energy is obtained through a medium which transfers the obtained heat at a higher temperature. There are three types of heat pump system. The first one is electric and engine roof heat pump, which is a closed cycle vapor compression heat pump. The second one is heat transformers heat pump, which are an absorption heat pump. And the third one is mechanical vapor recompression heat pump, which operate at 200 degrees Celsius. Next is the objective of the mechanical heat pump experiment. There are three objectives for this experiment. The first one is to determine the power input, heat output, and the coefficient of the performance of a vapor compression heat pump system. The second one is to produce the performance of heat pump over a range of source and delivery temperatures. The third one is to determine the performance value of the water pump system by taking readings at the four basic components of the system, which is the compressor, condenser, expansion valve, and the evaporator. Next is the apparatus for mechanical heat pump. There are 6 apparatus in this experiment, which is receiver tank, compressor, condenser, evaporator, filter dryer, and the last one is sight glass. This is the infographic poster we have prepared. You can pause if you want to take a closer look.
My name is Haikal Fitri bin Wad Ahmad Rizali, A1929078. So the first one is the result that we have got. We have cooling water flow rate in percentage and LPM. Cooling water inlet temperature TTS, cooling water outlet temperature TT6, compressor power input, heat output, and COPH. We record the data 3 times to reduce the error in reading data. Next, moving on to the observation. At the beginning of the experiment, the water flow rate was set as 40% after 15 minutes. The reading on refrigerant flow meter shows an increased temperature. The refrigerant flow meter shows reading of cooling flow rate FT2, cooling water inlet temperature TT5, cooling water outlet temperature TT6, and compressor power input. Throughout the experiment, the evaporator was always in a low temperature condition as it cooled the waste heat. Then when the flow rate of water reduced, the path of water to flow becomes small, and compressor increased the water pressure, and the pressure was measured by the refrigerant flow meter. In addition, there is a temperature sensor that acts to measure the temperature and a water flow meter and flow rate of water passing through it.
Now, I would like to talk about discussion for mechanical heat pump experiment. The heat pump is heat transferring mechanism. The evaporator is used to absorb heat in location and releasing the heat through the evaporator to another location. Some refrigerating system can reverse their service, thus making the evaporator function as a condenser and the evaporator as the condenser. By doing so, the heat flow can be reversed. Heat pump system work according to thermodynamic principle. It can be observed in the heat pump experiment that teach of the law of thermodynamics. Next, in the system, the cycle cannot occur while providing thermal equilibrium in the water container. It is because the cooling system has reached absolute 0 point by referring to the second law. It also refers to the third law of thermodynamics. Isotropic compaction at the compressor, heat transfer at constant pressure to the environment in the condenser, constant enthalpy expansion in the expansion valve, and heat transfer to the fluid at constant pressure in the evaporator. Last but not least, for discussion of mechanical heat pump experiment, from known as R1T4A table, it was used as refrigerant in the system. As in every experiment, this one also given some margin of error. The theoretical and experimental calculation results are different from each other. This is to mean that the finding of the study cannot be equivalent to the theoretical value due to reading mistakes which are made of the pH diagram of the refrigerant. The other reason is that the theoretical result depends on ideal cycle. There are also other factors that cause the different light friction and parallax error.
And the last one is conclusion and recommendation. As a conclusion, in reality, the coefficient of performance is less than ideal value. It is because of multiple reasons that cause inaccuracy or losses in the system, such as mechanical or electrical in the fan of the compressor, or errors in the measuring devices, especially when occurring the wet bulb temperature, WBT. In this experiment, the thermodynamic cycle of vapor, compressed heat pump and refrigerator were studied. The heat pump worked on a vapor compression cycle in which the refrigerant flowed through result 4 processes. First, evaporation at low pressure and temperature. B. Compression to high pressure. Condensation at high pressure and temperature. And the last one is expansion by throttling from high pressure to low pressure.